In this problem, we're asked to find VA of t. We're going to utilize our problem-solving strategy entitled Basic AC Analysis. So if you look, we have a circuit given in the time domain with two voltage sources and a number of circuit elements. If we look at our strategy, it says express V of t as a phasor and determine the impedance of each passive element. So if we look, for instance, our two resistors, we know their impedance is not a function of omega. But for our inductor, we remember that the impedance for an inductor is j omega L. Our omega is 50. So we have j 50 times 0.05, which is j 2.5 ohms for this inductor. For the one on the bottom, we have j 50 times 0.1, so that's j 5 ohms. For our capacitor, remember Z sub C is 1 over j omega C. So for the one on the top, we have 1 over j times 50 times 0.01. So that's for this element, and its impedance is minus j 2 ohms. And then for our other capacitor on the bottom, we have 1 over j times 50 times 0.005, and that's minus j 4 ohms. So now I've calculated the impedance of all our elements. The impedance for the resistors is just R. Now let's draw the circuit in the frequency domain. We're going to convert these sources over to phasors. So here's our circuit in the frequency domain. We've converted the voltage sources to phasors. The impedances are now on the circuit. And we have a single loop circuit. So I'm going to define a current I. And I'm going to calculate that current I. So if we apply KVL around this circuit counterclockwise, we'd have j 2.5 times I minus j 2 times I plus 2I plus 60 at an angle of 20 plus j 5 times I plus 5 times I minus j 4 times I is equal to 100 at an angle of 0, so that's applying KVL. And if we solve for I, yields I equal 6.73 at an angle of minus 37.3 degrees. So there's the current. Now, we need to calculate the voltage VA, and we can do that by either going around this loop or we could go around this loop. Let's go on this side. So if we apply KVL, we'll come up with the following expression. VA is 2 plus J5 times I plus 60 at an angle of 20. Okay, so that's using KVL around the left, going around like this. And if we calculate VA, that turns out to be 95.83 at an angle of 24.1 degrees. So there's the phasor VA. Now, for VA of t, we convert back to the time domain. The magnitude is a 95.83 cosine 50t plus 24.1 degrees volts.